This is the next video in the chapter on electronic structure and periodic properties. We are finally talking about electronic structure, and we have talked about orbital filling rules, about which order to load up those orbitals with electrons, and there are a few rules left that we need to talk about. Before we go into the next rule, I'd just like to point out that these lists that we're making, these electron configurations, are starting to become really long, and we can see that as we move on to elements that have more than 8 electrons, this is going to be a really long list. So this looks like a good place to introduce the shorthand electronic configuration, or the shorthand notation, because we are tired of writing these all the way out all the time. So the way we're going to make this simpler is we're going to separate all of the electrons that belong to a particular atom into two groups, the electrons that we care about and the electrons that we don't really care about. So the first type of electron is called a core electron, which sounds really cool. You can go home and tell your parents that you learned about core electrons and feel really good about yourself. But what really comes down to it when we're talking about bonding or reacting or anything interesting, these are not the electrons that we care about. So these are the electrons that live in the inner shells. And they are not used for bonding. They're still interesting, and some scientists still study them using X-ray experimentation. But if we're talking about figuring out whether an electron reacts with something or bonds with something, these core electrons are not going to give us any information about that. The interesting kind of electrons are called valence electrons. If you want to tell someone about something that's actually important, you can tell them that you know about valence electrons. So valence electrons are all of the electrons that live in the outermost shell. Remember that the shell refers to the N, the principal quantum number. So all of the electrons in the highest occupied principal quantum number live in the outermost shell, and they're called valence electrons, and they are available for bonding. These are the electrons that are actually used in electronic transactions. They're traded and they're shared and they're given away as bonding happens. And we'll learn about that a little bit more in the next chapter. So if we were to look at these long lists of electrons, we can identify which ones are the core electrons and which ones are the valence electrons. So the valence electrons are the easiest to identify first. So the valence electrons are all the electrons in the highest principal quantum number that you have electrons occupying. So for example, here's oxygen. I can see that we have electrons in the first shell and in the second shell. So the second shell electrons are going to be my valence electrons. So there are going to be 6 valence electrons in this case, 2 in the S and 4 in the P subshell. All of the other electrons that came before this particular shell are going to be considered core electrons. So in this case, these first two, the 1s2 electrons, those are going to be my core electrons. They're not going to participate in bonding, and I don't really care about them. But remember that it depends on which one the outermost shell is, which electrons you don't care about. If I was looking at something small like a helium, there is only one shell that has electrons in it. So therefore, all of the electrons are valence electrons because there's only one shell, so that shell is the outermost shell. And if we were to draw something bigger, we can skip all the way to argon. Argon has 18 electrons, and its configuration looks like 1s2, 2s2, 2p6, 3s2, 3p6. We can say that we have our outermost shell is the third shell. We have electrons in the third principal quantum number shell. So, oops, I put a subscript 6 by mistake instead of a superscript. There we go. So these 8 electrons are going to be our valence electrons. And everything else that isn't a valence electron is a core electron. So everything in the first shell and everything in the second shell is going to be a core electron. So in this case, there are 10 core electrons that we don't care about in argon. And so what we're going to do is we're going to be lazy, or rather we're going to be efficient, and we're not going to write this huge list of electron locations and orbitals anymore. We are only going to write the valence, because those are the only electrons we're going to care about in the future. So the standard notation is we're going to represent all of the core electrons as a noble gas. And the noble gases are in column 18, the very furthest right one on the periodic table. So here's what I mean. Notice that when we eliminated things, we eliminated them S electrons, and then we eliminated P electrons. So we went all the way to the end of a particular shell, which is represented by the rightmost end of the table. So if I want to eliminate one S2, what element does that look like? It looks like helium. So I'm taking out one helium equivalent from my notation because helium is here on the right side. So if I wanted to rewrite oxygen in the shorthand, I would write helium for all my core electrons, and then I would write the valence electrons afterwards that I actually care about. So in shorthand notation, we would write oxygen as helium, 2s2, 2p4. Or we can write argon. We want to leave out 1s2, 2s2, 2p6. And if we look, we didn't do that one, but 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6. That would be the same configuration as a neutral neon atom. So our configuration would look like neon to represent the core electrons, followed by 3s2, 3p6. So this isn't required. You are free to write out the entire electron configuration whenever you're talking about an atom, but I can promise you that once you start to get above about a dozen, you are going to get sick of this and you're going to be ready for the shorthand notation. So you write the nearest noble gas, the noble gas with the same neutral electron configuration as your core electrons, and you only report the outermost shell at the end after the abbreviation.